Hello, hello. Geometry. Ooh, yikes. Bad hair day, I guess. Hello, geometry. Oh, we're just gonna have to deal. Hello, anybody watching. Good to work with you today. This is Geometry 6.4. Today we are talking about this thing called similarity. It'll be a lot of fun. Woo-woo! We love similarity. Um, in order to better understand similarity, what I want to do first is touch back on congruence, which we've learned a ton about in our previous units. So, when we think of congruent, most students will say, oh, it's the exact same. Congruent means that we're dealing with the same thing, same size and shape. Yes, that's all exactly true. Today I'm just going to write it as congruent means that we have at least two things that are identical in form. They're the same. In our units talking about congruence, we primarily worked with triangles. Actually, I think we kind of just worked with triangles. And we were able to say two things. Well, let me say, if these are congruent, we know specific things. So congruent figures, here's our checklist for what we're looking for. Our first thing that we're looking for is we need to have congruent angles. The second thing we're looking for is congruent sides. Okay, this is our checklist. What that means is in this unit we said, oh, well, let me first label these. So let's say the left triangle is ABC. Come on, you can write. Thank you. It's easy as 1, 2, 3. Other triangle is DEF. So here, when I'm talking about identical angles, or congruent angles, excuse me, that means that if I write in this, each angle is going to have a congruent pair. So here, A is congruent, has a congruent match with angle D. Angle B has a congruent match with angle E. Angle C has a congruent match with F. We know those are the congruent matches because of how we write it. So I guess, for example, B has that one arc in the angle, and so that pairs with the one arc angle. The same thing is true with sides. So if we show that AB, we need to find in our other triangle a side that is congruent to AB. Each side has to have a congruent match in order to be congruent. If we have this information, then we learned how to write a congruence statement. That was when we compared these two triangles. So I'm going to zoom in real quick just so I can get some good handwriting here. That was when we would say triangle ABC is congruent to triangle DEF. Right? So these are the two elements that I want to talk about with congruence. what they have to have, and the statement that we can write. The reason I'm starting here is because when we talk about this thing similarity, you'll see a lot of, well, similarities between congruents, or with congruents. So our definition for similarity. My screen is wobbly today. Similarity, if you guess, you might get close. We're talking about two figures that have the same shape but different sizes. Come on, thank you. Different sizes. What that means is that instead of having two triangles, it's not going to click for me. We'll try it again. One, they're going to be identical in shape, same exact triangle, but they're going to be different sizes. What this is we're just talking about dilations. We're just talking about one is going to be bigger or smaller. So let's call this A, B, C, D, E, F, G, H, and I. The big triangle will be G, H, I. The smaller triangle would be J, K, and L. Why not? Ooh, let me move this so we can see. Just like with congruence, actually let me look up how we talked about, ooh, that's the eraser. How we talked about what congruent figures have. Let's do the same here. So, similar figures have these two things. Congruent angles, so that's the same as congruence, but they have proportional sides. We're not looking for congruent sides here, we're looking for proportional sides. If we have those two things, then we can write a similarity statement. Which, let me write this in real quick. It's going to look very similar to our congruent statement. We're talking about triangles, so what was it? GHI is similar to JKL. Notice here the difference between, I'll just stay zoomed in so we can see it. The difference is this. This is the symbol we use for similarity. Okay? It looks close to what the congruent symbol is, just a bit different. Other than that, our statements look exactly the same. So, I know I didn't write in these triangles like I did with the congruent one because I want to go straight into an example to help get a sense of what's going on. So, and we have 3 examples that we'll work through for the notes today. Here we go. I'm going to go ahead and show you this. And this. Ooh, is that going to snap? Nope, didn't snap. There we go, that snapped. You don't have to use triangles to be similar, by the way. I'm just doing this right now because it makes the math nice. And let me be careful here. The smaller triangle on the left we're going to say is EFG. The triangle on the right we will say is MLN. Just checking my notes. F goes with L, G goes to N. Yep. Then I'll also go ahead and write in the numbers. So and one more piece. Okay, if I give you this example and asked you to show me they're similar, well, you need to show me two things. One, do they have congruent angles? Well, when I look at angle F, does angle F have a congruent pair? Yes, has a congruent match with L. Does G have a congruent pair? Yes, with N. E has a congruent match with M. So, our first thing that we have to check off is there. We do have congruent angles. Now the question is, do we have proportional sides? Oh, there's our lunch bell. Well, we have 5 minutes till the next one. This looks like this. When we look for proportional sides, what we're looking for is we want the k value, our scale factor, to be the same for each pair of sides. I'll debunk this here in a bit. First, we want to set up our proportion. So, if I look at this side, FG, what side on the big triangle corresponds with FG? Here, the triangles are set up nicely that we can see it as LN. If these triangles weren't so beautifully drawn in, you can look here. Do you see how for FG, we start with the 1 arc angle and we go to the 2 arc? 1 arc. Why isn't it writing 2 arc? Well, that means on the big triangle, we want to start on the 1 arc and end with the 2 arc as well. So, swoop, swoop, we could say this. We could say that when we set up that ratio, we would want 30 over 18. Actually, before I write that, let me write it like this. We want Ln over Fg. I'm going to start by writing it this way. Well, when we say we want proportional sides, we want whatever our answer for Ln over Fg, we want that to match the others. So if I look at Eg, this side, that relates to Mn. So here, I would be writing Mn over Eg. And then that last side that we're looking at ML over EF, right? So when we do this math, we want all three of these pairs of sides to equal each other. Well, LN is 30, FG is 18, MN is 25, EG is 15, ML is 20, EF is 12. Let's go ahead and simplify these. I'm just going to type these into a calculator. If you wanted to reduce the fractions and just leave it as a fraction, that would be okay as well. When I type in 30 divided by 18, I get 1.6 repeating. I'll just write it that way. When I type in 25 divided by 15, I also get 1.6 repeating. When I do 20 divided by 12, I also get 1.6 repeating. So, in order for us to check off this box, we need to see that all three pairs of sides have the matching value. Do these match? Yes. They all are the same. So we do have proportional sides here. If we have check on property 1 on congruent angles and check on proportional sides, then we can write our similarity statement. EFG is similar to MLN. There you go. That is example 1. Let me say this. The big piece for today is this proportional sides. There we go. There's lunch. So we really want to focus in and make sure that we're understanding that proportional sides piece. Let's get a little more practice with example 2. I am going to show you this example doesn't have a triangle. Oof. Okay, we'll just take our time with this. Yep. Yep. And yep. So look away real quick. Hello? What? What is happening? Okay, here we're going to be looking at these shapes we call right triangles. Before we get started, let me finish writing in the information we know. And E, F, G, and H. Oh, and then the last thing we know, this is 1, 2, 3, and 5. This is 2, 4, 6, and 11. Same question though. Are these two shapes similar? Well, to show they're similar, we want to show congruent angles. Do they have congruent angles? Yes. This is kind of easy to see. We're looking for each angle to have a matching pair. Match, 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 match. The thing that we want to be careful with is this proportional sides. Proportional, I have to be very careful every time I spell proportional. Here, for proportional sides, well, we're still gonna be setting up our fractions. So here I see BC. What side does that correspond to or correlate to? That would be FG, CD pairs to GH, AD, EF, AB, and EF. I'm color coding them so we can see maybe a bit better where I'm getting these numbers. Oh, one thing that I didn't mention that I'll include here. When we set up a proportion, I'm going to set it up this way. 2 over 1. If I look at BC and FG, or BC and FG, we have 2 and 1 as our numbers. My question is, when we've talked about solving for K, we always do image over pre-image. Do we know in this diagram which one the image is and which one the pre-image is? No, it doesn't tell us. If it doesn't tell us which one the image or pre-image is, we get to choose. So because we don't know which one we start with, we can pick. I'm going to choose to do 2 over 1 to put the bigger trapezoid numbers on top, but it'll work either way. So I'm doing 2 over 1. I would also do 4 over 2 from GH to CD. I would also do 6 over 3 and 11 over 5. Once again, I'll go ahead and show you if you did the same thing, you just flipped your fractions. That's okay. That's okay. I'll show you what happens there. So let's go ahead and reduce. 2 over 1, that just gives us 2. 4 over 2, that gives us 2. 6 over 3, that gives us 2. 11 over 5 gives us 2.2. We'll come back to that in just a second. When we look at the other one, 1 over 2 is 1/2. 2 over 4 is also 1/2. 3 over 6 is also 1/2. 5 divided by 11 is 0.45. So the question, do all of these numbers match? The answer should be no. We see here there's this outlier, this 2.2 or this 0.45. They don't fit in. Because they don't all match, we don't have proportional sides. So if they don't all match, it's not proportional. Proportional. Yes, not proportional or not similar. So we can't write a similarity statement here because they're not similar. So this gives us a little extra practice looking at those proportional sides. I have one more example that kind of ties in some of our previous lessons. So example 3 looks at this. Thank you for clicking. Then I will copy, paste, shrink, and is there a way that I can we'll just leave it like that, honestly. These are, well, let me undo. There we go. So here, I do want to switch this example up just a bit. There we go. Here, P, R, and Q, I have similar triangles. Okay, now let me be careful because I need to. If I say PRQ is similar to LKJ, we would see this, LKJ. If, now actually, let me erase, oh, nope, we'll keep them there. If it tells us what the problem is, but it wants us to find a variable, this is where we're going to set up a proportion to cross multiply. So if I look at this side, RQ, in the big triangle, what side does that relate to? Oh, what side does that relate to in the smaller triangle? And let me, riddled with mistakes in this example. My apologies. I don't know what's gotten into me. Will 154 go with the 28 or the 18? Well, here's a way that we can check. Do you see how this 154 side has one piece on R and one piece on Q? Well, let's look at our similarity here. Do you see how R is the second letter listed and Q is the third letter listed? Well, that means that RQ has to pair with K and J. It goes by the same order. So we know here that 154 and 28 will go together. By that same thinking, when we look at PQ, well, here we see that P is that first letter, Q is the third letter. So when we look at our other triangle, it'll pair with LJ. Shoot. Of course I did it wrong. This is so embarrassing. Wow, I have really botched this. I guess we'll keep going. I am big apologies here on this example. Here we go, 15x over 18. The reason I'm saying big apologies is because I just told you, well, P and Q should match with LJ. Well, when we look at LJ, that's the wrong side. So really, we should, instead of writing this as, this should be, I should have written it as, yeah, go ahead and erase. JK. That way, the purples pair together and the greens pair together. Oh. Once we set up those proportions, let's just get over this example. We'll have 154 times 18, because we cross multiply. 154 times 18 is going to equal 28 times 15x minus 6 in those parentheses. We can work this out if you want to. I'm just going to go ahead and say, in the end, x will equal 7. You can do that distribution if you want, but x will be 7. Check me on that, maybe. Maybe that'll be my ask. Thank you for getting to the end here with me. I know it's a longer lesson than normal, but I appreciate it all the same. Hope you have a great day, and looking forward to 6.5. Goodbye.